Good morning and welcome back to Unit 10. Today we are on Lesson 5. As you know, we took a few days to review some material that was on our most recent assessment. So today we are jumping right back in to our unit on statistics. And today we are specifically going to be talking about changes to our median and mean. Quick refresher because I know it's been a while. We're going to start by looking at some of the vocabulary and terms that we learned before our little break from this unit to make sure we can jump right in. So as you can see here, there were three main new concepts that we learned in this unit before our break to review content. I'm going to go row by row, make sure you're following along with me and taking down any notes that you might need as a refresher because you'll need to know all of this in order to engage in the lesson today. The first was a statistical question, and we said that was a question that has more than one answer. So an example of a statistical question would be, how many hours did each AF sixth grader spend reading this weekend? We'll collect a data set that we could then analyze. If I asked, how many hours did Miss Green spend reading this weekend, that would only yield one answer, and therefore that is not a statistical question. The next is median. And we know that the median is the midpoint of a data set. And we know that it needs to be represented by one single number. The way we find the median is by listing numbers in order. Remember, we said that's the step a lot of people forget and is really important. And then we find the midpoint. So as you can see in the example column, if we had this data set, it's already ordered from least to greatest. I know I cross out from left to right. But remember, when there's not one number in the middle, but rather two in the middle, I need to find the midpoint between those two numbers. So halfway between 7 and 8 is 7.5. Lastly, the mean. That's the average of the data set. And we find the mean by adding together all the numbers in the data set and then dividing by the number of data points. So as you can see in the example here, 2, 5, 7, 8, 13, 9. When I add all those numbers together, I get 54. Then to find the mean, I needed to divide by 6. Remember, I got 6 because there are 6 numbers in my data set. Therefore, the mean of this data set is 9. If you need to, your teacher's going to pause the video for about 30 seconds or a minute to make sure you have this down if you need it, and then we are going to jump right into today's lesson. Let's jump in by looking at a think about it question together. We're going to read it aloud together, and then I'm going to send you guys off to engage in this on your own before you jump into a discussion with your teacher, and then we come back together. So follow along with me as I read. Think about it. Allie has taken 4 tests this year in math. She scored an 88, a 90, a 92, and an 86. She has one more test this year. What is her current mean and median in math? That should be easy. We just went over how to find both of those. When she gets her next test score, her teacher will find the mean and median of all 5 tests to determine her new mean and median in math. If Allie gets a 60 on her next test, which do you think will change more, the mean or the median? Why? Then part C, find the new mean and median of all 5 test scores by including 60 in the data set. So you have a series of 3 questions here. The one I'm most excited to see your answers on is part B, because that's going to be where we derive our key point from today. So in a second, your teacher's going to pause the video, you'll head into Desmos, and you're answering all 3 parts of this think about it on your own. It's okay if you're not 100% sure. This is new material. But you should try your hardest by using what you know about mean and median to engage with this problem. Then after your teacher sees all your responses, they're going to call on a few scholars to share their answers to parts A and B in particular before we come back together. Ready? Go. Now that you've had an opportunity to talk with your other scholars and with your teacher and to engage in understanding which of these changed more and why, let's actually look at some of the numbers here. Let's start with the mean. The original mean without 60 in the data set was 89. The new mean with 60 in the data set was 83.2. That means that when we added the 5th test score, our mean changed by 5.8. Now let's look at median. Our original median without 60 in the data set was 89. Our new median with 60 in the data set was 88. That means our median changed by 1. So if in your discussion earlier you said that the mean would change more, you were correct. There was a greater change in our mean, but why did our mean change more than our median when we added 60 to the data set? You're going to pause the video, go back into Desmos. Using this data, try to really understand why. As you're thinking about why, I want you to think about how we find our mean and our median. Then your teacher will call on a few scholars to share before we come together to stamp our key point. Go ahead. Welcome back from your discussion as a class. I am sure you guys had some really great ideas and were able to identify that 60 was an outlier in this data set. And that brings us to our key point. Adding or taking away an outlier typically affects the mean more than the median. And as we know, when we are finding the mean of a data set, we have to include all numbers in our calculation by adding them all together. But when we find the median, we are just finding the midpoint. So an outlier on the low end or the high end won't have a big impact on the median because we are just looking at that middle number. It might change, but it's not going to change as much as the mean because that outlier will be calculated into the mean when we find it. Again, to stamp our key point, adding or taking away an outlier typically affects the mean more than the median. We saw that through one example. Now we're going to apply it to another example to see it in action even more. We're going to read this interaction with new material together. It says, over the last 10 days, the temperatures in Miami, Florida have been 80 degrees, 78 degrees, 80 degrees, 76, 85, 84, 82, 79, 76, and 40 degrees. I wish it was that temperature in New York right now. The weatherman made an error and forgot to include the 40 degrees when finding the mean and median of the data. Should the weatherman report out the incorrect mean or the median in order to try to hide his mistake and report accurately about the weather? Prove your answer mathematically. So I want to just clarify here, because even when I read this problem, I was a little bit confused. So he normally would report, here's the mean of the weather, here's the median, but he forgot 40. He wants his mean and median that he reports out to be as if he didn't forget 40. So we're trying to find the mean or median that would be closest to the mean or median if he did include 40. So using our key point and what you know about this problem, should he report the median or the mean? When I say go, you'll pause the video, head into Desmos, choose your answer, and make sure you explain why. Your teacher will then call on a few scholars to share. Go. Hopefully you said he should report the median. Remember, 40 here is an outlier. So if we take 40 out of the data set, the median is likely to change less and therefore hide his mistake. So we know that based on our key point, but now we have to prove it using math. So we need to find the mean and the median without 40, and then we need to find the mean and the median with 40. Then we can look and see, did the mean or the median change less? We know based on our prediction that the median should change less, but we need to use math to prove it. Let's break this down. First, just find the mean and the median without 40 in the data set. That means you should only have 9 data points. You're going to type your answer into Desmos once you have it so your teacher can see, then we'll come back together to debrief. Go. You should have gotten a mean of 80 and a median also of 80. Remember, when you didn't include 40 in your data set, you should have had 9 data points. Now let's find the mean and the median with 40 in our data set. Now we know we have 10 data points. Do that now, type your answer into Desmos, then we'll come back together to debrief. Go. You should have gotten a new mean of 76 and a new median of 79.5. When you found your median, you noticed that there were 2 data points in the center, so you had to find the midpoint between those 2 data points. Did we prove that the median changed less? Yes. The median only changed by 0.5. It's very close to our original median. The mean changed 4, however, when we took out the 40 from the data set. Last question is, how did we apply our key point to solve this problem? Take a second to think about it, then your teacher will call on a scholar to share before we launch into independent practice. Just to review the steps that we took to find these problems. The first is to identify the change in the data set and predict the impact it will have. Are we adding a value or are we taking a value away? And based on the value that we're adding or taking away, will it have a bigger impact on the mean or the median? Then find the original mean and median and the new mean and median. That's the only way we can prove whether or not the mean or median will change more. Lastly, check for reasonableness. Remember, our mean and our median must be within the range of our data set. That's all for today, and I will see you for our next lesson tomorrow. Have a good one.